All right, so today's note is on linear quadratic systems. So if you remember back in grade 10, you were able to solve a linear system. Now what this is when you have two lines and you find their point of intersection. So to do that, you either use the graphical method, meaning you graphed both lines on the same grid and then you visually saw where they crossed. There's definitely some cons to this because it takes a long time. What if the point of intersection wasn't nice? Like, what if it involved decimals? And it's very hard to be accurate. Now, you could also use an algebraic method such as substitution or elimination. Now, I'm not going to go through how to do substitution and elimination, but we are going to be using substitution when we're solving linear quadratic systems, which is what we're doing today. So before we get into doing this, before we get into some examples, I want you to pause the video and I want you to think about what a linear quadratic system looks like. How could a line and a parabola or a quadratic ever cross and have a point of intersection? So pause the video right now, maybe draw a sketch, think about what that looks like, and then restart and we'll go through that together. So hopefully you've paused and you could start listening to what's going on here. There are three possibilities when we're thinking about a linear quadratic system. So the first possibility is that we have no point of intersection. So I'm just going to draw one quick example right here so that you can see what's going on. Let's say I have a sad little parabola like this, and I have a line that's way up here. So there's no point of intersection between this line and this parabola. Our second option is to have one point of intersection. So again, I'm just going to draw this sad parabola. There's a lot of ways that I could draw this. This is just one example, but if this line, if this line meets this parabola, and it doesn't really look like it meets there, but we're going to pretend it does, at exactly one point, it just touches the very, very edge of that parabola. That's an example of one point of intersection. And then I think what most of you probably thought about was something that looks like this, where our line crosses through the parabola, and so it would have 2 points of intersection. All right, so we're just going to get right into this. Find the point or points of intersection of the parabola y equals x squared minus 2x and the straight line y equals negative x plus 2. So we know, and I'm just going to write this in here for you, at the POI, both the x and the y must be the exact same for both equations. So the x and y must be the same for both equations. Probably should have typed that out, but that's okay. All right, so what I can do, and this is very similar to substitution, in fact it's the exact same, but now we have an x squared involved. I know that I can take this equation, this y equals x plus 2, and in the other equation, wherever I see a y, I can just replace it with negative x plus 2. So the second equation says that y is the exact same thing. It's exactly equal to negative x plus 2. So I'm going to write negative x plus 2 is equal to x squared minus 2x. So again, I took all of this and I plugged it in for the y right here. Now at this time, I can go ahead and I can rearrange this equation and bring everything to one side. So I'm going to move these guys over here. And so I'm going to get 0 is equal to x squared minus 2x. That's what I already had. And then this negative x is going to turn into a plus x. And then this plus 2 is going to turn into a minus 2. At this point, I can combine like terms. So I have x squared, and then I have this negative 2x plus x. So that's going to be just a minus 1x, and then my minus 2. Now we know a couple of ways to solve this. We've talked about how we solve equations like this. We can try and factor. That's probably going to be the easiest way. If it's not possible to factor, we are going to have to use the quadratic formula. So I need to think, is there something, let's just use a different color here, that multiplies to -2 and adds to -1? Now, lucky for us, there is something that does that. So -2 times 1 and -2 plus 1. So I can rewrite this as x minus 2x plus 1. And of course, we know how to solve this. That means that x is equal to +2 and x is equal to -1. I'm going to make this a little bit smaller. Whoops. This is a big mess right here. Let me see if I can make this work. There we go. So I have two options. Already I know there's going to be 2 points of intersection here. One of them is going to have an x value of 2, and the other one is going to have an x value of -1. So we know with a point of intersection, we need both the x value and the y value. So when x equals 2, I'm going to plug that into either equation. It doesn't really matter. I'm just going to use the easy one. Y is equal to -x plus 2. I'm going to substitute in that x of 2, and I'm going to get -2 plus 2, and so I get y is equal to 0. So that gives me my first point of intersection. The x was 2, and we just found the y to be 0. And I'm going to do it again. I'm going to say when x equals -1, again, I'm going to write that equation, y equals -x plus 2, y equals x was -1 plus 2. So this is 1 plus 2, which is 3. So this means that I have the point of intersection, an x of -1 and a y of 3. So therefore, 2 point of intersections at 2, 0 and -1, 3. All right, and our last example says, determine the equation of the line that intersects the quadratic function f of x equals -x squared plus 6x once if m equals 2. So we're given the parabola. We're given the equation of the quadratic. So one of our equations is y equals -x squared plus 6x. And we are not given the second equation. We know that it's going to be the line. So that's mx plus b, but the only thing that we're told is that the slope, or the m, is 2. So we know that this right now is our second equation. So we can go ahead and we can equate those. So I can follow the same steps for substitution. So I'm going to say that y is equal to 2x plus b, and so I'm going to plug that in for y in the other equation. So I'm going to get 2x plus b is equal to -x squared plus 6x. Now I'm going to rearrange this. I want everything to be all on one side. It doesn't matter what side you rearrange it to. I just like moving things to the right. So I'm going to move these over. And so I'm going to get 0 equals -x squared plus 6x. The 2x is going to become a -2x, and the plus b is going to become a minus b. I can simplify some of these. So a 6x minus 2x is a 4x. Now I'm stuck. I can't factor this. I still have a b in here, so I have to think a little bit harder. So what else do they tell me? What kind of other information am I given? Well, I'm told that it only intersects once. That is super important. We know that if something intersects once, if there's one point of intersection, then that leaves us with a discriminant of 0. So let me just write this here. Oh, not with that. 1 POI means that our discriminant equals 0. So we know that if it doesn't intersect at all, the discriminant would be negative. And if it intersects twice, the discriminant would be positive. I'm going to go ahead and write the formula for discriminant. We know it's just the b squared minus 4ac. So what's underneath the square root in our quadratic function? I'm going to set that equal to 0, and then I'm going to go ahead and plug in my b's, a's, and c's. So I know my a is -1, my b is 4, and my c is -b, which is super weird. So b squared, so 4 squared minus 4 times a, our a was -1, times c, and our c was -b. So 4 squared is 16. -4 times -1 times -b is a -4b. I'm going to go ahead and I'm going to bring this onto the other side. So 16 is equal to 4b. I'm going to divide both sides by 4, and I'm going to get that b is equal to 4. 16 divided by 4 is 4. Look it, I just solved my equation. I knew that it was y equals 2x plus b. I just found my b to be 4. So I know that the equation that crosses this quadratic once with a slope of 2 is y equals 2x plus 4.